Hello, everybody. I'm Ryan Puziak, a PhD candidate at the University of Ottawa, and I'm going to present to you data from one of my thesis chapters titled, Does an Ingredient in Beer Interact with the Endocannabinoid System? So first, I'm going to start with an analogy of the endocannabinoid system, which is the opioid system. So the body produces endorphins similar to morphine. They bind to a receptor and they're later degraded. They're useful in pain management. The endocannabinoid system is similar because the body produces cannabinoids that are similar to the compounds found in cannabis. They bind to receptors and they're degraded by these two main enzymes, FAH, fatty acid amide hydrolase, and MAGL, monoacyl glycerol lipase. Quite a mouthful. So anandamide here is a endocannabinoid, and it's broken down by FAH into phenylamine and arachidonic acid. That's later used as a substrate for other inflammatory pathways such as COX and LOX. This hops extract, in theory, would inhibit FAH and then result in less of that substrate. Previous literature on the subject, there's caffeic acid derivatives in echinacea responsible for FAH inhibition. That was work done in Dr. Harris's lab, the lab I'm doing a PhD in. And there's also been work on cannabinoids, in particular CBD, responsible for inhibition of FAH. So that's pretty cool. But I wanted to test it on hops. So it's a bittering agent in beer. It's a dioecious, which means male-female plants. A perennial, comes back every year. Bine, which means it kind of climbs up with little claws. And there's flowers and fruits that contain lupulin glands with unique chemistry, and they're harvested in late summer. There's a picture of the lupulin glands right there. And there are plant chemicals that are unique to hops, such as the bitter acids, humulones, and lupulones, prenylated chalcones, such as xanthohumol, and terpenes that are found in most plants, such as humulene and myrcene. So I selected groups based on their chemistry. So I selected 6 per group: high alpha, high beta, high xantho, and low total acids. And here's a HPLC chromatogram showing that the high alpha group in blue tend to have higher levels of alpha acids, humulones, and the beta acids tend to be higher in the high beta group in red. So my research questions: do hop extracts even inhibit FAH? And does inhibition change based on the chemical group, alpha beta acids or xanthahumol? This is the first time testing it, which will give a bioactive link between hops and the endocannabinoid system, which would be really cool. So FAH inhibition, as with most enzyme inhibition assays, there's a substrate and an enzyme, it produces a product. And if you include an inhibitor, there will be less product. So here, the substrate's AMCAA and FAH is the enzyme, it produces AMC and AA. And I predict that if you add hops, you're going to have less AMC. So the median concentration at 10 micrograms per mil showed that there is a difference among groups. High alpha around 52%, but all the other groups hover around 60% or above. And there was an effective, a significant effect of a group. So the discussion part of this: do hops inhibit FAH? Yes. Does inhibition vary based on groups? Yes. High alpha are poorer inhibitors than the other groups. And future assays would look at the arachidonic acid substrate pathways such as COX and LOX, as well as looking at MAGL inhibition. Future work may be linked to metabolomics, identify compounds that predict inhibition, and test cannabis. So the THC, tetrahydrocannabinol, or what I like to call the high compound, let's see how that competes against CBD, cannabidiol, or the compact down compound. So in conclusion, hops may help cure what ails you. And acknowledgements, everyone in the Harris lab, you've been great. Funding agencies, NSERC, Discovery Grant to Dr. Harris, OGS, University of Ottawa, family, friends, and God, and especially my wife, Amanda. So thank you for listening, and cheers.